Hello, good evening. This is Siddhartha Patel from Auto Sections. We are with our team, Kamlesh, Koiri, Bishanka, Krishna, Shrestha, Shiwani, Mishra, with the application called To-Do List. This application is a simple-based console C programming language. This application allows user to add and remove tasks from the to-do list. We are using linked list and stack in this program. Talking about the problem in the daily worlds, like we are having effective task management, and the traditional method have lots of limitations. This limitation have been removed by the to-do list applications. Talking about the problems that we are having are lack of motivations, perfectionism, time management issues, and we are having lots of unproductive materials. Implement this to-do list, we are having lots of objectives that in order to if manage the time efficiency, prioritize the tasks based on the importance on the deadlines, enhance the productivity with the reminder and time tracking. The organization can use it for various purposes, like to manage the overall tasks. In this application, we will be using various softwares and hardwares. Like in hardware component, we will be using i5 processor computer with 4 GB RAMs and lots of storage. And in part of like software, we'll be using for the programming, we will be using Visual Studio Code and GCC compilers and all. Further, rest of the thing will be carried out by Kamlesh.
I am covering the part of the to-do list application using the linked list. Here we have covered the two part, like two data structure to solve the same problem as prescribed by our faculty. So I am applying the data structure of linked list. So it's the workflow diagram, how the actually our code works in respective of the linked list. This diagram demonstrates the flow of the program starting from the user's choice, branching into different options including adding a task, removing a task, printing the to-do list, or exiting the application. The process continues until the user chooses to exist, where the program performs memory cleanup before terminating. Now I want to describe how this actually our programs works and how what are the function that has been used in this code. The program starts by including necessary header files and defining the structure for a task, which includes a description and a pointer to the next task. The global pointer to-do list is kept to keep a track of the head of the linked list is necessary to set a null indicating an empty list. Similarly, the add list function is responsible for adding a new task to the list. It takes the task description as an argument, allocates memory for the new task, copies the description into the task, and updates the pointer accordingly. The remove task function is used to remove a task from the to-do list based on the provided description. It iterates through the list, find the task with the matching description, adjust the pointer, and frees the memory for the remove task. Similarly, the print to-do list function is used to print the current contents of the to-do list. It transfers the linked list and prints each task response. The cleanup function is used to free the memory allocated for the entire to-do list. It iterates through the list, frees the memory for each task, and sets a to-do list pointer to the null. And similarly, in the main function, an infinite loop is used to repeatedly display the option for the to-do list application. User can choose to add a task, remove a task, print a to-do list, or exit the application. Similarly, the scanf function is used to read the user's choice and task description. The switch statement is used to handle different choices, executing the corresponding function based on the user input. The program continues running until the user chooses to exit the application. Upon exiting, the cleanup function is called free the allocated memory before the terminates. Overall, this function demonstrates a basic implementation of a to-do list application using a linked list data structure, allowing users to manage the task through a simple command line interface. And finally, when we run our code in the text editor like VS Code, then we got a simple output where we got the option of add a task, remove a task, print the to-do list, and exit. So here is a choice. We can choose option 1, 2, 3, 4. What we actually have to do for firstly we have to choose option 1 because we have to add the task. After that, if you want to print the to-do list, we have to choose option 3, and if you want to remove the task, then we have to choose the option 2, and finally if you want to exit our program, then we have to choose the option 4. Thank you. And further discussion will be done by Shiwani Mishra.
So good evening, everyone. So I'm Shiwani Mishra, and my topic is started from the analysis of the code. So starting with the time complexity, here you can see we can add, delete, and print, and also for the space complexity, same process adding, deleting, and printing. And now I would like to describe to-do list application using stack. So firstly, starting from what is stack. So simply stack is a linear data structure that follows the principle from last in first out, which means when last is inserted, that is the first to be removed. So this is the workflow diagram, and where you can see the initialization, menu loop, adding task, removing task. So simply you can initialize it from this all the process, and then you can exit the program. This is the code snippet for the stack process. Here task structure is defined, and this is for the. Now I'd like to hand over this to Bishanka for next explanation.
Okay, so now this will be the output of our to-do list application using stack. So you will get different option. Option 1, adding a task. Option 2, removing the task. Number 3, printing the to-do list. And the number 4, exiting. So according to the user's need, he or she can add the task, then remove the task, print, and exit the program. And this is the analysis of the code that we run using the stack. So the time complexity, for the time complexity, adding, deleting, and printing will be O of 1, O of 1, and O of n. And for the space complexity, adding, deleting, and printing will be of O of 1, O of n, and O of n. And so finally concluding that we all know that a stack is a linear data structure that uses the LIFO principle. That means last in, first out. So it depends on how we want the to application to execute this kind of code. Suppose if we want the sequential order, that means that we just want to print the to-do list in such order that the user had entered, then we will definitely use linked list is more preferred for such scenario. But suppose the user wants the last task to be printed at the first. Let's say sometimes in some scenario, the last task which the user entered may be important for him. So in that case, if the last task is important, then we will use the stack data structure to create our to-do list application. Thank you.